So what we're going to be showing in this video is basically how to use the steering function to make your robot move. So this is the basic steering block that we use to run the robot. These are all the different selections you can make under this first tab here. You can run your motors on for seconds, for degrees, or for the number of rotations that you want your wheels to spin. So I'm going to demonstrate what a couple of these different ones do. The first one here, this is going to go on for the number of rotations. So I have that set to 1 rotation right now, so that's 1 revolution of the motors. I'm changing the speed to 20, so that's 20% of the maximum speed it can go. That 0 over there represents that it is going straight with no turning, and I've set the braking to brake at the end. And you can see how that's B and C are the motor ports, and I'll show you what those mean. So that it's changeable, but that basically has to match up with how your motors are wired. So you can see I have the cable that's plugged into port B goes to the left wheel in my forward direction, and the cable that's plugged into the port C goes into the right wheel. So that is the way, that's the default way for this block to work, and that's the best way for you to use probably. So now what we're going to do, I'm going to show you how this works. So this is going to be 1 rotation, brake to stop at 20% speed. I'll give you an example of what this looks like. We'll do a bunch of tests here to show you what the different settings do. So you can see those wheels turned 1 full rotation. That was 20% speed. We're going to do the same test again. We're going to change the speed to 50% and try the same test again. You'll see this one will look quite a bit faster. So basically the exact same motion, just faster. Now I'm going to change this now to degrees. You can see when I change this, that automatically changes this thing here to 360. 1 rotation is 360 degrees. I'm going to change this to 90. I'm going to change the speed back to 20 as well. But the wheel should now turn 90 degrees. So you get a quarter rotation or 90 degrees of rotation out of the wheel. So if you look at that little marker that's on the wheel when we watch the video here, you'll see that it only turns 90 degrees. So this should go 90 degrees. So you can get very precise motor control when you're using the on for degrees. And then this last one here is on for seconds. This doesn't actually determine how far the wheels turn, but basically how long they run for. So this is going to be running for 3 seconds total. So 3 seconds and then a stop. So if you count there, that was 1, 2, 3 seconds that ran for. And the last thing we're going to show you here, I'm going to change this back to degrees. This is going to run for 360 degrees, but I'm going to make this coast to a stop. You'll see it won't stop as accurately this time. It'll just kind of, it won't do a sudden stop as soon as it hits 360 degrees. It'll actually just coast down to a stop. So you can see not as accurate there. So in FLL, when you're trying to position accurately to a set distance, you want to be doing probably a brake to stop most times. So now what we're going to try to do, I'm going to set this back to brake, set that for degrees, change this back to 20 as our speed. I'm going to change this to 1,000 degrees. Now what we're going to test here, we're going to try to figure out how far do we go in 1,000 degrees. So we're running forward 1,000 degrees, and I want to actually measure this distance, because what we're trying to determine here is what is the relationship to degrees versus actual real world millimeters. So I just ran forward for 1,000 degrees and then stopped and put a piece of tape down there and mark it. Then I'm going to measure between where we started from and where we stopped. So I'm going to measure this with a tape measure, and this is going to come out to be about 478 millimeters. So it looks like if I tell it to go 1,000 degrees of rotation, that translates to about 478 millimeters. So what I'm trying to do here is figure out how can I give it a value in millimeters and have that come up as the correct distance to travel each time? So I'm going to bring up a little comment window here, and I'm just going to comment in there. I'm going to say 1000 degrees is equal to 478 millimeters. And if you're doing this, you might get a little bit different results. Definitely if you're using different size wheels, you'll get different results, but this is what I'm finding with my experiments here. I'm going to do a little bit of math. I'm going to divide this. I'm going to say 1000 divided by 478 gives me 2.092. So it looks like I travel a millimeter for every 2.092 degrees of rotation that I try to travel for. So now what I'm going to do is bring up a math block, put that in here. I'm going to change this to multiplication. And in this second value here, I'm going to put in this 2.092. So the math block basically takes A, multiplies it by B, and takes the result and puts it somewhere else. So I can draw a data wire. So I'm using a data wire to take that result, put it into the degrees that I want to travel into my second block there. So the way this should now work is that whatever value I enter into that A parameter, it's going to get multiplied by 2.092. The result of that multiplication is going to get fed into the degrees that I'm telling the motion block to travel. So here I have some tape laid out. You can see that that was 1050 millimeters laid out there. So I should be able to key in 1050. I should be able to key that into this A parameter, and my robot should actually travel 1050 millimeters. So I've done that. I run my program, and hopefully that should stop right on that 1050 millimeter line. So middle of the wheel, right there. So that's pretty accurate. So this is basically some code that you can use to make your robot travel any distance in millimeters that you give it. That is the end of this video. The next video will show how to do basically the same thing, but being able to command it to turn however many degrees you would like. Thanks for watching.